Right, well today we're going to continue on using append2 to make a function that reverses a list. Alright, so what we want to call it reverso. I'm not going to call it reverse because there's already a scheme function called reverse, and we'll just show you how it works here. Reverse A, B, C, C, B, A. Alright, now before I do that, let me show you the real. There's actually a scheme procedure also that's called append, and it appends more than one list at a time. So I mean more than two. Oh, it can do more than two. So let's do like list A, B, and C, like D, E, F, G, X. Alright, there. See, it does it all. Alright, now then there's also a function called list that you know about. That's a little different. So what would happen if we put this here, except we change the word append to list? What will that give you? Now when I ask you questions like this, you can pause the video and like try and answer them before you find out what the real answer is. That's a very good way to learn. But I'm not going to, pause very long to actually let you think, so you'll have to pause it yourself. Except in this one case, because I've been explaining myself. Alright, so this is going to give you this. A list with a bunch of those elements in it. So there you see the difference between append and list. Alright, so now let's define reverso to do exactly what reverse does. So I guess the base case would be with an empty list. What's that going to give you? That will give you just an empty list. And reverso on that would a list of one element, that would just give you the same thing. Alright, but what about this? Reverso of A and B. Alright, so I mean obviously if we knew this was only a two element list, we could just cons the car of the coulda first, and then cons the car into the cons of the car of the list. So it'd be like, well, I won't show you that because we can't do that because we don't know how long the list is going to be. It might go on for a long time, so we have to make some sort of recursive thing that'll do it. And if we just use cons like we normally do, then you normally like cons the car of the list into the reverso of the coulda of the list or something like that. But that would just give you the list back. So what's sort of like the opposite of cons here? Well, it's append is well, it's not the opposite of cons, but it will do. Alright, so let's say we've got like alright, let's say we've got this. We can append the car. Let's define ls. Define ls. Oops. Define ls A, B, C, D. Alright, now what happens if we append the car of ls to the coulda of ls? Well, this is going to give us an error because append these lists. Alright, so let's do append the list of the car of ls. Append the list car ls to the coulda ls, and that just gives us the list back. But what could we do if we want to just put A at the end here? Well, we'll just flip-flop these arguments here. So we'll do append the coulda of ls first, and then the list of the car of ls, and then we get it. We get B, C, D, A. Alright, so then if we did that on just BCDA, then we get B back here and then CD, and then soon we'd have a reverse list. But when would we stop? And of course, when we're doing recursion, we stop when we get to the empty list. Alright, so let's define this. Define reverso lambda ls. Alright, then if null ls, then we're going to have to return the empty list. Oops, I don't know how that happened. Okay, otherwise we'll reverso oh no, we're going to append like we did down there. Append the reverso of the cut of ls onto the list of the car of ls. Now let's see if that will actually work. Oh, alright, now let's see. Reverso A B C D D C B A. That's just what we wanted. Alright, well that's good. I don't think we have time for mutual recursion on this video, so I'll just save it for the next one.